let me present you our own product developer and product designer. I'm not using the wrong words because this is my joke, but I honestly believe that Anthony, obviously his name is Anthony Lovchikov, and he's our product designer, yes, but he helps the product shine. And this is actually a great thing, and he'll be talking about one of those issues today. He'll talk about, like, I know nothing about it. He'll be doing all the talk, so let me just give him the mic. I'm sorry for the mess, but
yeah. Hi guys. Thank you. Yeah, as Kir said, my name is Anton Lovchikov, and I'm a product designer at Evil Martians. And recently, we began switching from RGB to OKLCH in our projects, both in design systems and front-end implementations of them. And today, I want to give you 3 main reasons why we decided to do so. And maybe it will be applicable to your situation. Before I start, yeah, let's play with the audience. Who among you guys are designers of any kind? All right. And who are front-end engineers? Nice. And which one of you heard about OKLCH? Something? Okay. And who thinks that it's a hype and there is no practical implementation of this technology? All right, yes. Will be very glad to have a talk in the bar after the talk. All right, so let's start. The reason number 1 is that OKLCH represents the visual observed characteristics of a color, and it talks to you and it talks to everybody in real world terms. And in order to understand it, let's quickly recap how we usually communicate about the color, how we say about it, how we talk about it. So for example, you can hear from a client or from a colleague that let's make this color lighter or darker. And you understand this concept. It's kind of ingrained in your world, your picture of the world into your brain. You know what is expected from you. Or somebody can say, please, like, increase the saturation. And you can do this also very easily. It's very understandable concept. Or somebody can ask you, please make it more like violet. And you also you know what is expected, what's the result this person expects from you. And in other words, we communicate about the color in terms of lightness, in terms of chroma, and in terms of hue. Lightness, chroma, and hue. And that's exactly what OKLCH means. L stands for lightness, C stands for chroma, and H stands for hue. Which means that, yeah, and OK part, I don't know what it stands for. I tried to Google it for some period of time, and the best explanation that I found, it stands for better, because there is another color model called LCH, and this is improved version of this model. And yeah, this abbreviation means that OKLCH notation actually contains the value, the quantable value that represents lightness of a color, chroma, and hue, and you can change them independently. In other words, OKLCH gives you 3 sliders which you can tackle independently, making color darker or lighter, less saturated or more saturated, and move it from red to violet, and any other values in between. And having these 3 sliders, it's very easy to fulfill the tasks from a client or from somebody with whom you are talking about the color. So if somebody asks, please make it lighter, you just grab the lightness slider and move it to the right. If somebody asks increasing the saturation, you take the chroma slider and move it to the right. And if somebody asks let's make it violet, you grab the hue and move it to the left. So OKLCH talks with you in terms that you use for talking about colors with other human beings. And what about the RGB? RGB also contains three components, but it doesn't represent real observed quality characteristics of the color. Instead, RGB represents the subpixel intensity. As you know, each pixel on the display consists of 3 subpixels, red, green, and blue, and RGB model says the display how much green to light, how much red to add to this color, and so on. In other words, RGB is perfect for talking the display, what you want to achieve, what color do you want to achieve. And it's quite bad in order to communicate the observed characteristics, as I said. Because RGB model gives you also 3 sliders, but these 3 sliders allow you to make the color less red or more red, less green or more green, less blue or more blue. And having just these 3 sliders, it's impossible or very, very difficult to process the tasks that you get from a human being. Please make it lighter. What does it mean in terms of these sliders? Where I should move it? I don't know. May increase the saturation. I don't know which slider I'm supposed to move somewhere. Even changing the hue, changing the color for violet, it's also impossible to do this with these 3 sliders only. And because of that, developers made some special color pickers existing on top of RGB model that somehow allows you to work with the color in more like predictable way. So you kind of have the hue axis and you can change the hue. It looks like you have now the lightness axis. So you can grab the color probe and move it to the down and make the color darker. And it looks like you have an axis for changing the saturation, the chroma. You can grab the color probe and move it to the left. But the very important to understand here that this is only the visual representation that exists on top of the same 3 components that I described previously. And practically speaking, it means that this color picker and RGB model doesn't know about the hue. It doesn't allow you to change the hue by some particular value or change the lightness by 10% or something like that. It just represents the same 3 components and that's it. Reason number 2 is that OKLCH guarantees, asterisk, consistent contrast ratio. And to understand this reason, let's take a look at the color spectrum of OKLCH. It looks quite weird. It has some peaks and valleys and some holes and so on, but it is done this way on big, great purpose. And the purpose is that if you draw a line throughout this spectrum and pick any color on this line, this color will have almost the same contrast ratio against white or black or any other color that you compare to. And that's a huge thing, because when you need to pick colors for active, for example, success states, warning on or error, everything that you need to do is set up the lightness at some particular value and just select colors that exist on the same line. And you will get the same, almost the same, and that's the asterisk, almost the same contrast ratio. For a constant ratio calculation in my talk, I will use APCA because it's yeah, much better model as I believe. And you can see that the values that APCA gives us almost the same. And the almost because there is no such term as lightness perceived by our eyes in real worlds. Everything is the question of math and calculation, and APCA uses slightly different model than OKLCH, and that's why the value fluctuates a little bit. But anyway, that's quite good, because... What? Yeah. And that's quite good. But you may say that, okay, like 4 colors, what the problem to pick them using the ordinary color picker? That's not a problem. I do it many times. But let's think about other use case when you have like dozens of colors and even more, like if these colors should be generated based on something. So for example, if you have a project where you need to generate avatars, default avatars for your users, what you going to do? Just picking these colors manually without having the lightness, fixed lightness. It's very tedious work. With OKLCH, it's quite easy. You set up the lightness, and you choose the colors for that exist on the same line, and that's it. And you kind of guarantee that the contrast ratio against this whites label will be good enough. It will be readable. It won't be like absolutely unreadable and so on and so on. And that's the kind of huge, because in RGB we also have this spectrum, but RGB doesn't have the idea of lightness. It's the spectrum just like pulled to the sides. It occupies the whole rectangle area, and yeah, looking at this spectrum, what we can say, it changes from red to kind of violet values, and it changes from black to white from bottom to top. And we kind of, that's like common sense. We can assume that if we draw a horizontal line across this spectrum, we also should get a consistent contrast ratio, consistent lightness. But it doesn't happen. Everybody here knows that saturated yellow, it's almost like white color, and saturated blue color, it's very close to black. It's very, very dark. And that's what APCA gives us. The contrast ratio for yellow is almost is 0, and the contrast ratio for blue is 91. So the difference is like very huge. And practically speaking, it means that if you use RGB model, the way of representation of the color and the way how you think about color, if you choose the colors for active, success, warning, and error, you will get inconsistent value of contrast, to the level that success is almost invisible. It's like very, very a low contrast ratio. And in order to address this problem, one of the solutions, what you can do, you can say, okay, I will use black labels against green and blue. But this solution, very, very bad. The front-end engineers will be pissed with that, because in this case, they need to think what color to apply to the label depending on the color of the button. That's a very bad solution. So you might want to fix this another way by adjusting slightly the lightness of this green and blue manually using RGB. And that's what you're going to achieve. You take the yellow and pull it down until you get the decent contrast ratio. You do the same with green, blue, and other colors. And all these things you need to do by eyeballing. There is no value that exists in RGB model that helps you to do that. everything is subjective. And it's very, very difficult. And by doing so, you can achieve the same situation, the same result that we get using OKLCH, but you will spend that's like maybe 10 minutes instead of a couple of seconds that we spent using OKLCH. Reason number 3 is that the favorite one, OKLCH helps to turn your color palettes into systems. And I will not talk about these huge tables with blue 500s, yellow 300s, I don't know, orange 800s that we saw in material design and in other design systems. I will talk about slightly different. Let's consider this example. I have 2 styles, active and success, with 2 states, normal and hover. I picked these colors for hover wisely using OKLCH. So they differs. Hover effect, hover color differs from normal state by the value that's present here, and by the same value, the hover effect for success style differs from the normal state as well. So my hover effect for both styles is almost the same. Not almost, the same. I increase the lightness by 10%, and I increase the chroma by 0.02 units. And since the difference is the same between these 2 styles, I can extract it, wrap it into modifier, and use for calculation the hover effect without need to set these colors like directly. So I can like remove full row of hover colors, and instead of that, I just say that, okay, I need a hover effect for success. What should I do? I take the normal state of the success and increase the lightness and chroma by provided value. And when I need a press state, for example, I establish a new modifier that decreases the lightness, decreases the chroma, and it exists as a modifier basically. So when I need a press state for warning, instead of like setting this color manually and having it somewhere written in a static way, I have all the states calculatable. Take normal color, apply modifier, and I get the produced color that I need. That's very, very cool thing, because when a client comes to you in this situation and says, hey, I hate blue, let's switch it to violet, everything that you need, just change one value for active style, and the rest, hover and pressed states, will be recalculated automatically. I don't need to go and change it in my config or something like that. I'm talking about front end, yeah, for sure. In Figma, you still need to have the explicit colors. In hex and RGB, that's the problem, yeah. But yeah, in the real project, it will be automated, and there will be no case when you changed the hover but forgot about press states, and now you have inconsistency. That's eliminated by using this system. And the situation might be that a front-end engineer comes and say, we need disabled states for all these styles. And that's also not a problem. You invent a new modifier, and all the values for all the colors is calculated automatically. And they are consistent. That's the very big point. And what about the example with the automatically generated avatars from previously? This is a pseudocode that's not like real, but it represents the idea, what happens here. Instead of picking like 30 or 40 colors manually and having them fixed for these avatars micro projects, what we can do? We can write a function that takes the name of the user, applies some mathematics, and converts the string into integer that's frames from 0 to 360, and that will be our hue value. After that, we feed this hue value in OKLCH notation as a hue parameter, and we get background color. We slightly change the lightness and feed the same hue, and we get the foreground color. And all these avatars will be automatically generated for you. Depending on the logic inside of this function, these colors may be like hundreds, many hundreds. It depends on the logic inside this function. And that's great. You don't need to support all these infinite amount of colors manually. You just describe it mathematically, and OKLCH allows you to generate as many colors as you need. What about RGB? Can we do something similar using RGB? No. Here's the same example with the same two styles, with the same two states. And here's the notation using RGB for these colors. Let's do the same trick. Let's see the diffs between the hover style and normal style. And as you can see, the diffs are different. So which means that we can't extract it. We can't make a universal CSS modifier that can be applied to any color for producing predictable hover effect. We can't do that. And practically speaking, it means that the project that uses RGB still needs to have all these configs with all the colors like a snapshotted existing in the fixed way. You can't modify them, you can't automate them in any way. And all these colors need to be picked using your eyes, your skill, your designer knowledge, because it's quite difficult to select colors for hover, for example, that looks similar when placed one to each other. It's very difficult to control chroma, to control lightness, and so on. Again, because color pickers, RGB color pickers, doesn't have this idea. And this table, yeah, might look nice and well organized, but when a client comes to you and say, let's change it to violet, what you are going to do? You are going to recalculate, repick, reselect all these three colors manually, again, remembering about that all the hovers should be consistent, somehow fixing it. And what happens if a developer comes and says, I need a disabled state? The same. You need to create the whole new row of colors, selecting them manually, thinking about consistability, and so on. And reason number 3.5 is that OKLCH allows you to use P3 colors. Modern screens, modern displays, because of new technology, are capable of displaying much more colors that they used to display previously. And in order to drive these modern displays, the engineers made special color space called P3. And if you somehow set up the color of your project that lays in P3 color space, a user on modern screens can see much brighter, more rich colors, and so on. Users on older screens will see a fold back colors that exist inside sRGB. And modern big companies started adopting P3 already. This is a tweet from developer from Versal, and where he shares how they switched from RGB to OKLCH notation and increased the juiciness of their landing page. If I managed you to become interested in OKLCH, you can read more about the deep things, deep model how it works in our blog. Now, we wrote a couple of them, so you can search them in our website and get more ideas why OKLCH better than HSL, which also gives you 3 axes of lightness, chroma, and hue. And yeah, adopt and adopt OKLCH. And also, I would like to show you our color picker for OKLCH, OKLCH.com. And I use this color picker for all my slides when I need to select a color in OKLCH color model. It's very nice because it explains all these weird-looking spectrums that's produced by OKLCH. So yeah, please take a look, and let's try and give it a try. Try to use OKLCH in your next project. Thank you very much.
Thank you, Anthony. Any questions for him? Please do.
Yes, firstly, thank you for OKLCH.com. It's a great playground to understand how it works. It really helped me to get a grasp of what OKLCH is. But I want to ask you, from the talk, I didn't really get how does HSL fits this narrative, because it definitely got better support, but not all the capabilities. Can you explain a bit more?
Okay, we have a questions. Let's recap it first. Please don't forget that.
So the question is that how HSL fits to this story of comparing the RGB and OKLCH. And I would like to get back to the spectrum of RGB. So RGB doesn't have axis, real axis that lies here on the edge of this spectrum, and HSL actually invents this axis. In other words, as far as I understand, I might lose some details, but HSL, it's the very same RGB with the same capabilities, but with additional mathematic on top of that, which allows you to change actually the lightness, chroma, and hue as a value. So it's additional, like a function that exists on top of RGB and stores the value for these 3 components. And after that, it translates it into RGB. And it means that the spectrum that's produced by HSL is very similar to that, to RGB one. And it doesn't look like this, because it doesn't changes the, it's a very, very like lightweight mathematics. It doesn't change the, in other words, the lightness of HSL is not perceptual. It's the same lightness as you see in color picker of RGB. And OKLCH, it's a kind of next step. They applied additional mathematics to that and said, okay, actually one line should produce the colors that looks like their lightness, looks like the same. And that's why when they did it, these holes and peaks appeared on the spectrum. So OKLCH, it's just the first step to get in something like that.
What if we pick on the bottom?
Yeah.
Value here?
No, we will not have. Sorry. Yeah, the question is that what if we move this line below these valleys? What will happen if we choose the color that exists somewhere here? There is no color. There is no color because physically, our eye, the color wave doesn't produce color that have this lightness, this low lightness, and these amounts of chroma. That's like physically impossible. And OKLCH is like honest in this perspective. And comparing to RGB, you will always get some value, but it will be like a stretch. They basically took this displays, pull it down, and that's why you get all the values regardless of the kind of a composition of the axis. And yeah, OKLCH frankly says that if you try to do this, there will be no color. But that's very important to understand. Yet we don't have the color. You can see here lines, and these lines present P3 color space. So before some points, we didn't have these colors. But technology runs, goes forward, and now we have these colors. Maybe in some time, we will have these colors or that colors. And in this case, this intersection of axes will produce some color. Any other questions? Oh, sorry.
Did I get you right that Figma doesn't have OK support?
Doesn't have, yes.
So how do you solve this problem?
Yeah.
Plugins or something?
Right. So the question is how we work with OKLCH and Figma, since Figma doesn't support OKLCH natively. So first of all, there are plugins that allows you to enter the OKLCH notation. OKLCH notation, something like that. And it produces the RGB color that corresponds to this notation. That's the first place, the first part. And but we don't only want to use like select color in OKLCH and use some color in our Figma. We want to communicate a new way of establishing a color with the front-end engineers. And in this case, what we do something that I showed on these slides. We say that our, yeah, something like that. We say our active color is that, and for using inside of Figma in our mockups, we still use hexes, we still use RGB, but the real color that developer will implement in the front end is that written as a text. And we just established this language with the front-end engineers, saying that don't copy the RGB hex code. Copy the OKLCH and use it in front-end.
That's clear.
Thank you. Yes.
That was exactly the question I wanted to ask.
All right. Yeah, the same question. Who else? The same question. Okay, the lady had the question about dealing with OKLCH and Figma, and yeah, that's the same answer. Yep.
What's about the fallbacks in terms of CSS with all browsers?
OKLCH has its own fallback. You don't need to care about it. The browsers they started support OKLCH relatively recently. So, and they developed this support in the way that if you put here, there are like two types of the fallback. One of them is what if you selected a color that lays in P3. In this case, they have the internal way of falling back to one of sRGB color. That's the one thing. And another thing, what if you selected here unrealistic value, like 100, like 2 or 3 with some hue. In this case, they also have a fallback to the nearest color that can be displayed on the display. So they have built-in fallback system. You don't need to care about it.
No, I mean, if the browser does not support OKLCH.
Then that's a good question. I think that you can ask this question from Sitnik. He will explain more about this fallen back. So far, as I understand, all the modern browsers support OKLCH, and if you use OKLCH and a user opens your website with on some old machine with old browser, I don't know what will happen. Will be there presented something. Maybe they have they not the front-end engineers. Maybe they don't only write OKLCH notation, but there is some special comment in that. If yeah, I don't know. Ask Sitnik.
I'm sorry, I have to hard stop. I'm sorry, guys, I have to hard stop the questions because we have limited time yet. I'm sorry, Anthony. We have to deal with the questions that we already had. Which one was the best to your taste?
I think the supports in Figma, but I don't know how to split the first place between two persons.
I suggest you both guys and girls come to me, find me just on my break. We'll figure out how we can split the merch that we have because obviously it won't fit everyone. So we will figure something out. We can do that, I guess.
Right.
Congratulations.